Hey everyone, thanks for coming. So today I will talk about customizing the EVM. And we have two parts to this presentation. So first I will talk a little bit about the theory and what we can do with EVM customization in the Avalanche network. And then I'm very excited to also present one of our Codebase cohort participants. So Codebase is our accelerator program here at Ava Labs, and we're building companies for the Avalanche ecosystem. We have 2 batches a year. Each company gets a 50,000 stipend. In the next batch, we're only going to accept 7 companies. And then these 7 companies, they will compete for a $1 million prize pool for investment. So today we have George here. He will take the second part of the presentation. He was of the first cohort that just ended. And we're going to talk about how they can leverage, customize the EVM for their project. So I will talk a little bit about the theory, and then we're going to see a practical application of it. So I want you to, for this first theoretical part, I want you to think of a blockchain similar to as a highway, right? Like where every transaction is a car on that highway. And you can kind of think of the highway that, like how long these transactions take. It's about the time to finality, so how long do you need to your destination. But more importantly, the throughput is the number of lanes of the highway. So obviously what we want to do is we want to build high throughput systems, right? And this is really the scaling approach of Avalanche. So what we think is a trivial way to achieve a lot of throughput is move from a single blockchain with one validator set to a heterogeneous network of blockchains with multiple blockchains and multiple validator sets. So thinking about the highway analogy, how can we build a very wide highway that can, process a lot of cars, process a lot of transactions? Almost trivial, right? Like we take all the validators, they validate one blockchain, one highway is built. Then we take a subset of these validators. They validate another blockchain, and we just keep doing this. And as you can see here, we can build a very, very wide highway, but just building multiple highways in parallel. And it's the same thing for blockchain. Our scaling approach at Avalanche is almost trivial. We just have a lot of combined throughput of these blockchains in the Avalanche ecosystem by just running them in parallel independently. And independently is very important. So if you just watched the presentation of Steven, he talked a little bit about ACP77. So in the future, what we're going to move away from are these subsets, and we're going to move to distinct validator sets. But everything I'm going to talk about today is true for the first and for the second approach. This one has some benefits, as Steven just described. But everything I'm talking about holds for the post-ACP77 scenario as well. So what is this independence, right? Like we do have nice properties, like for example, there's high load on one blockchain, similar to a traffic jam on a highway. It doesn't affect other blockchains. But more importantly, and that's what I want to talk about today, it's customizability, right? When we think about this highway model, right, in theory, we could take a highway and we could dig out a lane and fill it with water if people wanted to travel by boat. But it will be much, much more easy if we build them in parallel and build a canal next to a highway instead of, trying to combine everything in one. And this is what we're talking about today. And it's really one of the key value propositions of why you should launch your own blockchain. Right? One, does it make sense? There are things like gas tokens, higher throughput, access control, but even one of them is just EVM customization. And it will come in, as you will see in a bit, that you can use that if solidity is just not sufficient or economical for what you're trying to do. It really opens a lot of doors there. So let's talk about EVM customization. The very simplified model of the Ethereum virtual machine is you have a consensus and networking layer. It's called Gasper in Ethereum. You have an execution layer, the EVM itself, and you have the smart contract layer, so where people write Solidity, right? So we can see this layered layout here in Ethereum. Avalanche is a little bit different, right? We do have a shared consensus and networking layer between all the subnets, all the blockchains of the Avalanche ecosystem, but it turns out every blockchain here has its own execution environment. So as you can see here, we have here 3 blockchains in the Avalanche ecosystem. They're all using the EVM as an execution environment. Avalanche is VM agnostic. So we could go one step further and even depart from the EVM, build a Move VM, build a Solana VM, whatever it is. But let's assume now we like the EVM for our 3 blockchains here, and we want to stick to them. So since we have independent execution environments, now we're certainly in a position to customize these EVMs to our needs, right? And this is really the power, and I'm going to present 2 ways how to do that today. They are put in these 2 categories. So with the EVM, what we can do, if we don't want to write a single line of code, we can get pretty far already by just configuring the EVM differently than maybe the C chain or Ethereum main chain, right? You will see the EVM can maybe certainly fit your project if you just add some different configurations. The next step is modifying the EVM, right? You can take the EVM as it is. You can build on top of years, decades of research, right, that went into the EVM, and then you can just extend it without reinventing the wheel. And the last thing is, if you wanted to depart from the EVM, and we're not going to talk about that today, you can build entirely new virtual machines, for example, with the HyperSDK, right? So this doesn't even require coding. This requires a little bit of coding, but nowhere close to you're going to write your own virtual machine, right? So let's think about configuration. You know, one thing you can easily do without, you know, writing a single line of code is just saying, like, maybe we want to restrict who can access transactions on our blockchain. You know, that doesn't mean that it has to be a centralized entity, but maybe this access to this blockchain is administered by a DAO or by a KYC provider or a set of KYC providers, right? Like, so that's really the idea here. You can also say, you know what, anyone can interact with my blockchain, but I certainly don't want anyone to deploy contracts there. So let's say you're a DeFi protocol, you want to have it permissionless access to that, you're running on a permissionless blockchain in the Avalanche ecosystem, you say, like, I'm happy for anyone to trade on it. I certainly do not want anyone to come to my blockchain and deploy Tornado Cash on it. You know, like, maybe for compliance reasons, maybe just because you don't want to have competing applications for the same block space, right? If you want to have your own highway, you want to make sure it's purposed to a certain purpose and nothing else gets into the way and has any effects on your ecosystem. So this is pretty straightforward. This is like almost trivial. So if we think in our highway model, you know, it's kind of like putting checkpoints at the beginning, and that will just leave certain transactions on the actual highway. But now we're going to talk about the more interesting part, the modification of the EVM. So let's say, you know, like just tweaking the EVM to your needs isn't enough. There's something very powerful in Avalanche. It's called precompiles. It's also part of Ethereum. Ethereum also has precompiles. Maybe you heard it before. But usually these precompiles cannot be, you know, like introduced by protocols. It's like the whole community in the Ethereum ecosystem. They agree on precompiles, and it's like really only a small set of precompiles that benefit the entire ecosystem, because an entire ecosystem is sharing a single chain. In Avalanche, protocols can have their own chains. Therefore, they can also leverage this very, very powerful tool for their own needs. Right? So precompiles is nothing that Avalanche invented, but precompiles are something that Avalanche is making available to the general developer. So I want you to think of a precompile as something you use a Go implementation. So you implement the precompile in Golang, but it is wrapped by a Solidity interface, so developers can interact with it as if it was a smart contract. And you will see, I will present some code here in a little bit, that the developer that is interacting with the precompile can't actually really tell that it is a precompile. You know, it behaves like a contract, it looks like a contract, I use it like a contract, but I implement it entirely different. So let's look at this example here, right? I just created a very, very simple example for a SHA-256 hash function precompile. You can see an interface here. It's called iSHA-256. It has a single function, hash with SHA-256. Takes a single parameter and returns the bytes. And now I have a contract here. And as you can see here, there's no implementation on how this hash function works, right? It's really just an interface, right? It's just an interface up here that tells me what functions does my precompile have, what parameters does it take, what return values. Now in my contract, you can see in line number 10 that I instantiate my SHA-256 precompile, and you can see something very odd. I will talk about this in a little bit, but the address looks already very, very odd, not like a regular contract address. Oh, now I stepped on the... I hope we can recover. I just put it in again. because that's going to be, this part would be very, very hard to explain without a slide, not going to lie. I'm glad we recovered here. Okay, so now we can see in my contract, I have this function do something, right? Could be any logic, and I'm just doing like only the hashing. So I even call my precompile here, hash with SHA-256, like a function, like a general contract. So you can see here that we can use this really as if it was a regular smart contract. And now we're going to look on the implementation side. So you can see already we're changing languages. We're changing to Golang. And what we can do now is, you can see up here, I'm omitting a lot, but like we can see here, we can now just import any Go library that there is, right? Like could be crypto SHA-256, could be whatever it is. And then we are implementing the function here, and we have a bunch of parameters here. But at the end of the day, we're doing some packing, unpacking, but at the end of the day, the logic is implemented here. And we are just using this Go library here to do this hashing. So we have an almost trivial example here, but you can basically build any logic in this precompile as long as it is deterministic. You can't do server calls, you can't use randomness, it has to be deterministic, but you can do whatever you want here. You could build a whole DEX as a precompile if you wanted to, right? You can also access state, you can put stuff in the state, you can read from state, all this kind of stuff is possible. But it is really powerful, especially this part here, because precompiles are not only nice when it comes to performance, because Go is a lot more performant, but most importantly, you can use existing libraries. This will enhance your security. Go is a much more adapted language than Solidity. They have a rich set of libraries that is well audited. You can just use that. ZK, all kinds of stuff. We will hear about very interesting use case for TEEs in a little bit, right? Why reinvent the wheel? Why re-implement something in Solidity if it's available in Go? Just use it there. And you can also use, like advanced features that are just built there, right? So this is really the concept of precompiles. And before I introduce George to the stage to talk about how they plan to use this in their project, I'm more than happy to take any questions about the theoretical part first. Do you guys have any questions? Yeah? Oh, most certainly. Yeah, you can definitely implement access control. There are different patterns. You can do it either on the precompile level. I mean, at the end of the day, you can also set kind of like the cost of calling a precompile if you don't want to worry about it. So kind of like anyone who wants to pay for using a precompile, they are free to do it. But you can most certainly build access control similar as we know it from Solidity smart contracts into the precompile itself. Yeah, but like, let's say you wanted to do like a ZK proof verification in a precompile, it will have a certain price. If someone wants to use it, why not let them use it, right? Like if they pay the price, it's all good. The important thing is to price precompiles correctly. So not have like some heavy computation in Go and say like it costs 5,000 gas or something, right? Like then you run into a DOS vector, but if you price it correctly, there's actually no need to restrict access. Any other question? Yep.
How to calculate the gas cost of a precompiled function?
Yeah, I mean, that's you will have to check like the computation that is done, right? And then a good thing is like take the Ethereum precompiles as a reference. But yeah, that's pretty much. I think like maybe just pessimistically a little bit to not run into any issues. But as long as it's not entirely mispriced, I would even argue that the Ethereum precompiles are priced like just around about. All right, then I would say let's go to the second part of the presentation.
Hey everyone, as Martin mentioned, my name is George and I'll be telling you a little bit more about Axon, which the way we put it is the world's first decentralized clearinghouse. Now I have a question. How many of you have heard about the collapse of FTX? Maybe we're surprised. So yeah, obviously, if you look at the whole thing that happened 2 years ago, many people woke up realizing that they don't have access to their virtual assets anymore, and that was it. But if you think about it as a user, what are the ways that you can transact between traditional fiat world and crypto? You can either go with centralized exchanges, which offer very competitive pricing, but at the same time, you have this custody risk, and you hope that you're not going to pick the next FTX. You can also also decentralized exchanges make the interactions with DeFi protocols very clumsy, very hard to do, and so on. They're not the best thing to use if you want to reach the DeFi world easily. Now, you have the alternatives like on and off ramp solutions like MoonPay, Transact, Wire, and the others, which in my opinion, they're providing much better user experience if you want to reach DeFi, but at the same time, they're charging you a lot. We're speaking about 2, 3, 4, 5% in fees. And by the way, they're still custodial. They still get there is custody risk for 5, 10, 15 minutes. Many people will be fine with that, but in the end, they're a custodial solution. So what we're building is basically, in essence, a decentralized clearinghouse, which is able to allow users for the first time to transact between fiat and crypto without any custody risk. And that's what we're building. And let me tell you how it works. Before we begin, we must understand the problem in more details, because to solve a problem, you need to kind of go into the details to understand it in a better way. If you have traditional finance and crypto, basically in traditional finance, what in many cases will happen, people can move funds between different bank accounts. And it's a very minimalistic way of looking at the world, but that's what you do in traditional finance. You move value of some kind of money between different bank accounts. In crypto, you do the same between wallets. But there is also one nice addition in crypto. You can basically also interact with smart contracts directly. So you can, for example, deposit in a yield-bearing protocol, or you can do some trading on a decentralized exchange or something like that. Now, again, very minimalistic way to look at the world, but in essence, that's all you do. The problem is you cannot transact directly between the two worlds. That's impossible. And right now, as mentioned, there are two main ways that people do it. They would, in many cases, just go to a centralized exchange or centralized financial institution. They'll deposit the funds, and at some point, they'll get the crypto in their wallet. Now, where it becomes tricky is when there is a situation in which the bank might request a recall. So this will happen if there is any type of fraud. So for example, somebody might steal your debit card, they might buy crypto on some exchange, and they might run away with the money. Then you realize, hey, this was a transaction they didn't authorize. So you call your bank, the bank reaches out to the centralized financial institution, and the centralized financial institution in many cases is required by the regulators to return the money. But remember, if the money is out in crypto, there's nothing you can do. So what will happen is decentralized institutions which already have custody risk will also impose these lockup periods. In the US, you go between fiat and crypto, and in many cases, you need to wait 10, 15 days to get outside of the centralized exchange. And the reason is risk management. They clear the risk from the transaction while you're basically sitting on Coinbase, for example, or any of the other solutions. And that's how they deal with this type of risk. Now you can go to on and off ramp solutions where you deposit funds, you get the crypto in just a few minutes, and obviously, these are still tapping into centralized liquidity in many cases, private market makers, centralized exchanges, and so on. But yeah, I mean, the custody risk is just for a short period of time, 5, 10, 15 minutes. Maybe many people will be fine with that. The problem becomes once again when you have a recall. Again, these solutions offer the proposition that you get the money very quickly. And in many cases, if somebody steals your card, you're not going to find out that there was some kind of fraud in the next day or two. So what will happen is by the time that basically the recalls comes in, this company no longer has any type of access to the funds because these funds have been sent to the user. They cannot do anything to return the funds. And they bite the bullet. Basically, they need to pay out of pocket for all the fraud and compliance issues that they might experience. How do you counter that? By increasing the fees. You basically, it's kind of like insurance. You make sure that everybody pays more, so you can basically do something if there is fraud and you need to pay out of pocket. You offset the loss. That's the essence. So this is the current status quo. This is what we're used to. And we think this is normal. At Axon, we don't believe this is normal. And that's why we're here to solve this. So how do we do that? And how does Avalanche plug in the whole entire system? So quick recap, in crypto space, all you do in essence is move funds between wallets and interact with smart contracts. Simple as that. Minimalistic way to look at the world, but that's all you do. We call this the DeFi space. So here is where our innovation starts. We basically start by building a wrapper around the whole DeFi space, something that we call a secure transaction space. And in the secure transaction space, there are a few things that are interesting which are happening. Each crypto wallet 1 has an equivalent wallet, secure wallet 1, and crypto wallet 2 has an equivalent wallet, secure wallet 2. Only crypto wallet 1 can control secure wallet 1, only crypto wallet 2 can control secure wallet 2. It's kind of like a projection of crypto wallet 1 to the secure transaction space. And basically, these wallets can move funds between each other. They can also interact with smart contracts. In essence, they do the same thing that you do in regular DeFi space. You move funds between different wallets, and you also interact with smart contracts. And this is possible because in crypto, everything is interoperable. So all the existing smart contracts allow you to operate, to access them. So you can basically directly, every secure wallet that exists can directly tap into the existing smart contracts. Now, in essence, this is a self-custodial wallet where you can see your funds in real time. And you can also, again, execute actions. You can send funds between the different secure wallets, and you can also interact with the smart contracts. That's what you do. Now, that's cool, but where does fiat come in? We have something that we call fiat initiating company, and this is external to the decentralized clearinghouse. So this is a company which is not part of the protocol, okay? So you don't need to trust this company. That's how we have built it. And this company gets regulatory approval to operate in a specific jurisdiction. It integrates to KYC and payment providers. It performs active AML monitoring, so making sure there is no money laundering. And it initiates fiat funds transfers. That's all it does. And obviously, you can have one. You can have another. You can have third one. Imagine in the future, maybe a big brand like Visa decides to do this type of thing. They can plug in directly into the protocol as one of the fiat initiating companies. The responsibilities that they'll have is just around regulatory, money laundering, and initiation of payments. That's it. In the beginning, obviously, this is Axon because it's easier to launch that way. So the first such company is launched by Axon. It's actually two of them, one in US, one in Europe. And basically, this company is here. Now, as we discussed the typical flow of funds, you would have somebody sending fiat, and then you pass the crypto to the secure wallet. And that's fine. What will happen if you have a recall or for some reason, whether it's fraud or missing payment or whatever? Well, the secure wallet is designed in such a way to actually be able to support recalls. But remember, you shouldn't trust this company here, as it's not part of the protocol. So what do we do then? We have built another thing, another part of the innovation is what we call the incorruptible computing network. And this is a network which basically is connected to over 10,000 financial institutions already. And it has a certain type of connectivity that ensures end-to-end cryptographic guarantee that no one can cheat when they fetch the information from the bank and when they pass it to the crypto space. So basically, they ensure some type of end-to-end encrypted line of communication between traditional finance and the crypto space. Think about it as your WhatsApp. If you send somebody a plain text message via SMS, people with enough skill set to hack and so on, they can hijack it, they can read it, they can change it. With WhatsApp, the promise is you have end-to-end encrypted flow. And basically, nobody can sit in the middle and change the information. This is the approach we're taking here as well. So basically, we're building this secure communication channel between the traditional financial industry and the crypto. And through this channel, there is specific type of enclaves and TEs that are running. Basically, they produce specific type of reports and quotes. So you can think about them as cryptographic proof as well, which basically are then passed to the security preserving blockchain. which, by the way, is based on the L1s that Avalanche provides. And it has like a specific consensus algorithm, which also uses precompiles, I'll tell you how in a bit, to basically make sure that every proof that is generated from the incorruptible computing network is additionally validated to be legitimate proof. If there is a consensus that reaches out in this, among these validators, basically the proof is forwarded towards the secure transaction space. And at this point, you have this communication channel with multiple checks and balances and security measures and decentralization that make sure that you can transfer all the information without any chance of that anybody corrupts it. And at this point, when you have the signal here, you can basically automate things because this secure wallet, in essence, is a smart contract. It can read the signal and directly act on it. And when this happens, you can close the whole circuit. You can basically build automations around it and prevent fraud in various ways. So let's look at a simple example. How do you make a non-custodial flow of funds? So when a user says, I want to transact, the first thing that will happen is this company will proactively check for AML and compliance issues. And if they say, OK, everything is good to go, they will allow the user to move forward. And at this point, basically, there would be a transaction which pre-deploys capital in the secure transaction space out of liquidity, and this capital sits here. So at this point, if the user sends the fiat in the next, let's say, 20 minutes, there's no worries, and everything goes as planned forward. Now, if the user, for some reason, decides not to send the money, what will happen is this company will detect it. And when it detects it, since it cannot do anything, it cannot recall the funds, but it can reach out to this independent third-party judge, the way you can think about it, so the incorruptible computing network. It can send a signal that there is some kind of missing payment or something like that. Reaching out to this third-party judge, it will ask it to verify it. And when this network basically reaches out to the traditional finance institutions and produces a proof that there is really a missing payment, there will be the signal. And once the signal comes here, basically, a recall is possible because then the secure wallet can automatically reverse everything. And that's how you build non-custodial flow of funds. The user never has custody risk. The user never provides funds before they get in return something. It's kind of like if we meet in person somewhere and I want to sell you my phone, and if you give me the money and I have both the money and the phone, in theory, you have custody risk. I can simply run away. But if I give you the phone before you give me the money, then you have both the phone and the money. You cannot have any custody risk in that scenario. And what we have built, however, protects the business from a situation where the user doesn't provide his part of the bargain. And this allows us to really have this non-custodial experience end-to-end and to allow transactions to be facilitated at a reasonable price. Now, this is also, we have similar type of networks for fraud and compliance. There are various things around them and a lot of details, but I'll not go into them. But in essence, all of this allows to have fast, non-custodial, low cost, and fully interoperable solution with DeFi protocols. So you no longer have to have these situations where you either need to choose between custody risk or high price and so on. You are able to use your DeFi protocols. In the meantime, we clear the risk from the transaction. As long as you don't do anything fraudulent, you won't even notice. And that's it. That's Axon. How it all works, again, with the security preserving blockchain, which is, again, the bridge and the thing that allows us to have endless security of the protocol, because basically with the Avalanche L1, we can basically really scale our security infinitely. And how we do that, in essence, is the following. And why, in general, we chose Avalanche for the security preserving blockchain. So first, it's very easy to deploy this. Like we were playing with the idea of having our own blockchain. There were reasons why we didn't push forward in the early on, simply because it's taking a lot of resources to do that properly. And with Avalanche, this seems much easier, streamlined, and nicer experience for anyone who is developing it. So that's a major plus for us, and that's something that I actually really liked. And on the other side, you have the whole capability that also Martin explained about, like how you can use the precompiles to basically both allow for easy deployment of a modified consensus algorithm. So we actually have a control over the consensus. and we can build a custom consensus algorithm through the subnet technology, the L1s, and we can have full control over it. So a few examples. The validation of the TE attestation collateral, which is coming from the incorruptible computing network, we can do it through the precompiles. And basically, when we're doing this validation, we're checking for various things. We're checking for the validity, so making sure that everything is correctly signed and all of that. We check the metadata, which is generated for the trusted computing base and so on. And on top of it, we can even have our own specific policy of how we act based on the information that we have just processed around the metadata parameters and the security parameters in place. And we can do this, all of these type of things during the consensus of a transaction that is passed to the network. And it's quite powerful. Now, what does it lead? The combination of those two leads to the following. You have infinite scalability, as I mentioned, of the security model, as well as solid tokenomics that we can put in play. Because now we can also have the token to basically provide this kind of security of the network. People pay in Axon to have the whole protocol operate and so on. And this makes the whole system complete and really secure. So that's in essence what we're building and why we also went for the L1s and why we find them to be a very powerful addition to our stack, to put it that way. Do you have any questions?
Yeah. Can you go back a couple of slides where you had the architecture, let's say the smart wallets and
Yeah.
here, thank you. So it's interesting that you said how, let's see, the interface between the TradFi and the crypto space happens with the signals, and the secure wallets can read the signals and execute based on that.
Yeah.
So my question is, will this be, let's say, limited within the scope of Axon protocol, or is this something you plan to make it composable?
Yeah. Yes. So the short answer is we do plan to make it composable, but we do start in the beginning through focusing on our retail experience, which is the Axon 360 that I mentioned. And in the Axon 360, you see it's kind of like Coinbase with zero custody risk. So yeah, I mean, in the beginning, we start simple, and then we will, in time, allow people to connect directly and to offer this connectivity to different dApps directly.
Once the end-to-end trust channels are fully established, maybe used to communicate, for example, with collateral pools and collateralized stablecoins, for example?
There is another product that we are still keeping under wraps, because the question is, can we use this end-to-end secure communication channel to do various things around real-world assets? In essence, that's my understanding of the question you had. And the answer is yes. And we have a byproduct which came out of this solution, which I think will be also quite interesting and powerful for many users, but it will be announced soon. But yes, it can be used, and I think this is also important part for things that you can do around RWAs as well. And we will plan to probably allow even people to build even cooler stuff. I mean, we have one use case that is very useful to us, and that's why we're creating an RBI product. But I think there are various ways to utilize this technology, and we'll be thinking of ways to allow people to plug into the whole communication channel plus security preserving space to allow them to support those use cases.
Basically, an on-ramp that we're talking about.
And off.
Is there also like a plan to create an off-ramp?
Yes, apologies. By the way, I was speaking about the on-ramp part so much that I forgot to mention that it works in both directions. The flow is different, but to be honest, the on-ramp part is the difficult part. The off-ramp in many cases can be easier, and we support it even with our app. By the way, is it possible to, oh, it's kind of, yeah. Because where I was going with is, if you want early access, please sign up, and you can experience both the on and off ramp fully non-custodially. We, for example, fiat to USDC and USDC to fiat, it goes as low as 0.2%. So you can enjoy this. In Europe, we are already letting people try the app. In US, it's coming in just a week or two. And we'll be happy to take any feedback that you guys have. Off-ramp is supported.
Would it mean that my funds will be in the secure wallet for some time and I cannot basically touch them? So the problem of like funds stuck somewhere for a certain period of time still exists?
So, yeah, so you're right. In the secure transaction space, we do have some certain restrictions, right? I mean, you are able to use the protocols that we are integrated with. In the beginning, we start with a small set of protocols. In the future, in theory, we can support all the protocols. The main restriction is around basically moving funds from the secure wallets to the EOAs. This is something which will be restricted for a limited time. But keep in mind, every EOA on this world has an equivalent secure wallet, no matter whether the person is in Axon or not. So in theory, you can always send money to the equivalent of a specific EOA in Axon, in the secure transaction space. They can always just go in and take the funds out. That is always going to be possible. You're right, there is some restriction, but if you compare it to an experience that you have in centralized exchanges. Like in a centralized exchange, you don't see where their assets are. You have no idea where they're sitting on in the right place, somewhere in a kind of like custodial solution, or whether somebody bought a yacht with them. You know, you never know. You don't have real custody over these assets. You cannot prevent somebody taking those assets. You cannot move those assets. And worse, you cannot even interact with your DeFi protocols. So that's the current solution that people are used to. And if you move large amounts of money, you still go to a centralized exchange because it still provides you the lower fees. And you bite the bullet on all these problems and experience these issues, and that's it. With us, we basically allow you to have real-time visibility over the assets. You're able to even move them in specific protocols and enjoy the system. And we're not able to do anything funny with your money. So those are the main differences. Any other questions? Cool. Well, guys, again, we're excited if you will try the app, and would love to get any feedback. And yeah, hopefully you like the service. Thank you.